In general, currents in seas and oceans can be divided into two general categories: surface currents and deep currents. Here we concentrate on the surface current. The wind is the main parameter that drives surface currents in the ocean and sea. Wind should constantly transfer energy and momentum to the ocean surface to generate currents. Surface currents usually move near or 50 to 100 meters from the surface. In addition to the wind, two other factors change the direction of these currents. One of them is due to the topographic shape of the coasts, and the other factor is the result of the Earth's rotation. Topography or bathymetry and forces due to the rotation of the Earth mostly change the direction of the current, while the wind gives these currents energy to move. We know the coastlines and topography are not straight and full of twists and turns, so the current path is constantly changing. The Earth's rotation also forces currents to move to the right in the northern hemisphere. But, in the southern hemisphere, the current diverts towards the left side because of the rotation effect. So, we can observe many currents when moving on the surface of the ocean with circular paths. We name them eddy or gyre. Gyres are rotating currents that are usually permanent or have a longer lifetime, but eddies usually have a shorter lifetime. Among all ocean currents, all of us are familiar with Gulf Stream. This is a warm and swift Atlantic Ocean current that originates in the Gulf of Mexico and flows through the Straits of Florida. This current moves up the eastern coastline of the United States and moves toward northwest Europe as the North Atlantic Current. The width of the Gulf Stream can be 100 km with a speed of roughly less than 2.5 meters per second. There are many eddies and some gyres in the ocean. Among all gyres, 5 of them are more significant: 1. Indian Ocean Gyre, 2. North Atlantic Gyre, 3. North Pacific Gyre, 4. South Atlantic Gyre, 5. South Pacific Gyre. Are there eddies or gyres in the Caspian Sea? According to our understanding of the prevailing wind of the Caspian, what is your opinion about the surface currents of the Caspian? The attempt to understand the Caspian surface circulation dates back to about 80 to 90 years ago. Between 1935 to 1937, efforts were made to present a schematic for the surface circulation of the Caspian Sea. Finally, Lednev in the year 1943, presented the first schematic figure for the surface current of the Caspian Sea. Caspian currents are in the form that the surface current from north to south is moving from the west, while the current on the eastern coast is south to north. If we look at this direction of the Caspian currents, we understand that their movement direction is counterclockwise. A few years later, scientists presented a better and more complete picture of the currents of the Caspian Sea. Now, after about a century, what is the circulation of the Lake Caspian? What do you think? Today, our understanding of the Caspian surface currents has increased, mostly due to the advancement of satellites, images and computers. The schematic proposed by Lednev is in good agreement with our current knowledge. The progress of science has helped us to only see the details of the behavior of the Caspian surface current. Wind, topography, and coastline, Earth rotation, and Volga River are 4 factors which form Caspian Sea circulation. Volga River affects the surface circulation of the Caspian Sea as a large volume of water enters the Caspian Sea. The Volga River usually drives a north-south flow when it enters the Caspian Sea, which exists until near the Absheron Sill. The flow due to Volga discharge is usually less than 10 cm per second. The prevailing wind moves the water from the North Caspian side to the middle side. But due to the topography of the Caspian and the coastline, the current forms a circular movement in the entire Middle Caspian, which we can call a gyre because it exists throughout the year in the Middle Caspian. In the South Caspian, the current flows in a counterclockwise direction, but due to the topography, it is separated from the coasts and forms different eddies in the South Caspian. All these eddies are formed in the areas of the South Caspian where the water depth is more than 500 meters. If we compare Lednev's schematic with the present map of the Caspian Sea circulation, we will understand that there are many similarities between them. But 80 years ago, Lednev's figure did not show the South Caspian eddies well, but with the progress of our science, we can find such eddies today better. Again, the main circulation of the southern part is counterclock like the middle basin. The average surface currents are different in different months in the Caspian Sea. On average, the currents of the Caspian Sea are usually less than 1 meter per second. The maximum speed was recorded in August, while the average speed can be 0.56 meter per second. In March, the minimum average speed was recorded as 0.18 meter per second. Most currents on the coast of Iran are from west to east, and their speed reaches 50 to 70 centimeter per second in some seasons, like autumn. In December, the current strength is the very high in the north, middle, and southern Caspian Sea. The maximum eddies can be detectable this month. Indeed, the Caspian surface circulation is very complex.